Okay, so here is the first question. Your code today is 317. Go ahead and just answer A right when you start the question. And then when you are done with the question, switch from A to B. And do parts A and B. Okay, so about half of you are done. Give 1 or 2 more minutes. Okay. So let's go over this question. So the first question is, what is the cycle time for this processor? How do we do this? Why do we add them all up? Why do we add them all up though?
Cycling every single step.
Do we go through every single step? Okay, so what's my longest instruction? Load word, right? So we add them all up because our longest instruction does use every single part, which is load word. If our longest instruction didn't use every single part, then we didn't need to add them all. Like if our longest instruction was, say, R type, we don't use memory, right? Okay. My pen is not working. I need to relaunch PowerPoint. Okay. So if our longest instruction was R type, we'd fetch, we'd decode, execute, and then go straight to write back, right? But our longest instruction is, so longest is load word. Load word will fetch, it does decode, it does execute, it accesses memory, and it writes back. Store word is not our longest instruction because store word does all of these except it doesn't write back. Okay. So longest instruction is load word. So cycle time is 40, 45, 52, 50, 60. What is this? So this is our cycle time. And this is for single cycle. Now, if we add a new instruction that can element-wise add two vectors together, this makes the execute stage now take 80 nanoseconds. The question is, what percentage of instruction count must be lowered by this new instruction in order to achieve a speed up? So first part of this question is basically asking us to do what?
Difference in speed between the two latencies and then.
Simpler than that. It's the first thing I need to figure out in order to new cycle time. Yeah, so new cycle time. So again, this is going to be single cycle. CT new is what? We're increasing execute stage, right? It's going from 52 to 80, so it's increasing by 28. So we need to add 28 nanoseconds to this. So that is 247 plus 28, 5 nanoseconds. And now execution time is what? So let's do ET old is instruction count old. What's CPI? What's cycle time? And then ET new. We don't know instruction count, right? What's CPI? And what's cycle time? And then what's speed up? I see old times 247 divided by I see new 275. And what do we need this to be greater than to achieve speed up? And now we just need to solve for the ratio, right? Which is just what? And what is this ratio? One what? So we need to reduce by we see how to do this? Okay. So now let's do the same question, but you have a pipeline processor now.
For exam purposes, do you need to define an instruction count, or can we keep it as just a variable? If it's another ratio thing, that's.
If you will oftentimes have to do this. Like, I mean, you don't have to do this in this case.
Mhm.
Like you can give the instruction count a fake number. But for like if I just made this pipeline like I just did, your fake number might give you a different answer.
So,
Because if you pick like a very, very low number, like say it's instruction count of 6, then the time to fill up the pipeline makes the CPI not approximately 1 anymore.
so it's better just to keep it, it's just IC instead of.
Usually, yeah. Sometimes fake numbers can help students, but sometimes it can change your answer, like I just said. But if you understand the problem and you know, like, I need to make this fake number very large, then that can work too. Okay. So do the same question, but now pipelined. And change your answer from B to C when you are done. Now change colors. Okay, about half of us are done. We'll give just a little bit more time. But for those of you who are done, if the people are around you done, maybe you can discuss before we go over it together. Okay. Looking around, doesn't look like people are working on this anymore. So, first question, what's the cycle time? How do we do this? For pipeline? Not quite. So that is the instruction latency of all instructions, right? But we're asking for cycle time. Longest stage. So what's our longest stage? So it's defined by longest stage, which happens to be right back. So CT is 60 nanoseconds, right? So then if we add a new instruction, and now execute stage is 80 nanoseconds. What's CT new? Yep, 80 nanoseconds. And then we would do the same thing of ET old, ET new, and we would get the same thing over here. That's IC old over IC new. And let's just do this. And we would have 80 over 60, right? The setup is the exact same. It's just cycle times are changing. And this is so in this case, we need to decrease instruction counts by 33.3%. Right? Yeah, nice. So this is your homework question, so I meant to hide this slide. So here, since we're running out of time, let's just do these together. Just want to remind ourselves about these different control signals in our data path. So for an R type, and let's just go one signal by one signal. What does register destination need to be? What does branch need to be? What does mem read need to be? Does it need to be 0? No. No. What does mem write? Well, what's next? Mem to reg. What does mem to reg need to be? What does ALU up need to be? What does it need to be?
Like 0, 1.
Right. Let's just say that it's R type, right? This is perfectly fine. If you don't remember what the 2-bit code is, R type is fine. Because R type, what is it telling us to do? Look at func code, right? And then if it's load word or store word, if you don't remember, just say it means that we should add, right? So the 2-bit code is not super important. The functionality is what is important, right? And then if it's a branch, what does it need to do? It's supposed to subtract, right? Because it subtracts and then detects if the output is 0 to see if they're equal. Mem writes. What does this need to be? Yes, this needs to be 0. ALU source. And then reg write. Yes, we are writing to the register. Right? So then for load word, these signals are a little bit different, right? Regdest is reg 0. Branch is mem read. Mem to reg. Yep, 1. Because we need to get this data. ALU up. Or just add. Mem write. ALU source. Reg write. Store word. Register destination is we don't care, right? Branch. Mem read. Yeah, we don't care about reading from memory. Mem to reg. Yep. ALU up. Or add. Mem write. Yep, we are store word. ALU source. And then reg write. Yep. And it's because reg write is 0 that we don't care about destination, mem to reg, or if we are reading from memory, right? All right, so now for branch. What's my destination register? Yep. Branch is mem read. Does it need to be 0? Yep. Mem to reg. Yep. ALU up. Yep. And then Mem right. Has to be 0. ALU source. And then reg right. So just make sure that you're very familiar with the data path. And for the exam, you have the study guide. You have all of the practice problems from the slides. You have your homework. Right. So
How will you be able to bring a study note card?
yeah, same thing. So all exams are going to be the same front and back 8.5 by 11 sheet. And again, it doesn't have to be exactly 8.5 by 11, just as long as it's not obviously much larger than that. Okay, so homework is due Monday. Your exam study guide is due, if you choose to do it and submit it, Wednesday before the exam. Okay. Yeah, new reading is due on Monday because we are going to cover new content on Monday. The content from Monday will not be on the exam on Wednesday. So
Posting the marked slides.
yep.
Thank you. You just-